Hello, in this video we're going to learn about adding and subtracting polynomials. On the left here I have a list of vocabulary terms that I'm going to be using during the lesson. First one, monomial, is a real number, a variable, or a product of a real number and one or more variables with whole number exponents. So that's a lot of stuff in the definition here. It's actually pretty simple. Let me write some examples and that'll give you an idea of what a monomial is. 5 is a monomial. 3x would be a monomial. 10x squared y would be a monomial. And finally 5x over 3 would be a monomial. So polynomial, I'm going to skip ahead for a moment, is the sum or difference of monomials. Okay, so we need lots of monomials. So 3x squared plus 5x plus 7. This would be a polynomial because notice the difference here. This is a monomial, this is a monomial, this is a monomial. But when you start putting addition signs in between them, now they become a polynomial. Okay, so it's many monomials. Here's another example of a polynomial because you can have subtraction as well. So 4x to the fourth minus 7xyz plus 52z minus 8. Okay, this is a polynomial. You could have as many variables as you want in each monomial, okay, but once you start breaking them up with addition or subtraction, then it becomes a polynomial. Okay, so each of these four things individually would be a monomial. If you started putting addition and subtraction in between, it would be a polynomial. So the degree of a monomial is the sum of the exponents of its variables, and the degree of a constant is 0. This is a constant, it has no variables, so its degree would be 0. So if we want to call it degree, this is 0. Sum of the exponents of its variables, so the degree of 3x would be 1 because it has an exponent of 1 here even though it's invisible. This has a 2 and a 1, so we're going to add those, so the degree is 3, and the degree of this one is 1. Okay, and we're going to use that in a moment. So adding and subtracting monomials. You've been doing some of this your whole life, right? 8 plus 5 we know is 13, so that would be adding two monomials to get 1. 4x minus 2x, we've been doing that. That is 4 minus 2, so 2x. Then we have 7x squared plus 14x squared would be 21x squared. And then here we have 11x squared y cubed plus 2x squared y cubed would be 13x squared y cubed. It's actually pretty simple. You just add or subtract the coefficients. 8 plus 5, 4 minus 2, 7 plus 14. Okay, let's get down to the next one. 10x squared minus 3x. This you cannot do. Cannot be done. Meaning, so if you needed to simplify this, you cannot do 10 minus 3 because the variables, although the same, do not have the same degree. Okay, you need to have the same variables with the same degrees, or you cannot simplify it. So you would just leave it as this. If I said simplify 10x squared minus 3x, you would say 10x squared minus 3x, or can't be simplified. Same thing with this blue one down here. They both have x's and y's, except the x has a degree of 2 and the y has a degree of 1 here and 2 here. So even though overall they both have a degree of 3, each variable has to have the exact degree. Okay, so this can also not be done. So the simplified answer of this is this. Okay. The standard form of a polynomial is when you put the monomials in order from highest degree to lowest degree. Okay, so by looking at this, we can see that 4x cubed to the third, right, is the highest degree, because this one has a 3, a 2, a 1, and from before this has a 0 degree. So to put it in order, we just write 4x cubed. It's really important to keep the sign with the monomial that goes after it. Okay, so this is not a 3x squared, it's a minus 3x squared or a negative 3x squared. And then obviously when there's nothing in front, it's a positive or a plus 8x. Okay, so we have 4x cubed, and again, since we moved it to the front, we can take away the plus. Then we go, this is the second, so minus 3x squared. Then we have a positive 8x or plus 8x, and then a plus 5. Okay, so standard form is pretty simple. You just look for the highest degree, put that first, and then go in descending degree order. Now naming a polynomial can be done in two ways, and we often do that at the same time. You can name them by degree. Let me give you an example of a degree 0 polynomial. Well, it's really a monomial, so 5 you would call a constant. If we said 6x plus 5, so you look for the highest degree, and it's 1, so we would call that linear. If we had something like 3x squared plus 7x, we look for the highest degree, which is a 2, and we call that a quadratic. And then if there was a 3, so 4x cubed plus 2 or something, the highest degree is 3, so it would be called a cubic. Now you can also name them by number of terms, so a monomial, 8xyz. So this would be a monomial. And then a binomial would be 2 terms, so we could say 3x plus 7 would be a binomial. A trinomial would have, as you guessed it, 3 terms, so it could be something like 5x squared plus 4x plus 3. That would be a trinomial. And then we can put that together. So if I had, let's see, 8x squared plus 3x plus 7, we would call this the degree is 2, so we would call this a quadratic, and then there's 3 terms, so trinomial. So this would be a quadratic trinomial. So you look for the degree for this term, and you look for the number of terms for this term. So you could have linear binomial, you could have a linear trinomial, or a cubic monomial, cubic binomial. Alright, oh yeah, going back to this. Once you get to the degree 4, you just say like 4th degree, 5th degree, and so on. And with terms, you don't usually name something with more than 3 terms, so I don't even know what it would be called, so don't worry about that. Alright, simplifying by adding polynomials. So when you have these 2 big polynomials, and you know there's 2 of them because I have them in parentheses here. Here's one of them, and then here's the other. So we're going to add these together, and so what we do is we're going to combine like terms, which like terms are things that can be added or subtracted, monomials that have the same variables and degree. So like these are like terms, these are like terms, these are like terms, these are like terms, and these are not. So these could not be added or subtracted. We're going to combine like terms. So 3x to the 4th is the first thing I see. That's the highest degree. I don't see anything else that goes with that. So I'm just going to put 3x to the 4th. Then I see a minus 5x cubed and a positive 6x cubed. So again, you got to remember that the sign goes with the monomial to the right of it. So a negative 5 plus 6 would be positive 1. So we're going to say that is plus 1x cubed, or just plus x cubed. Okay, then we have a 2x squared positive and a negative 3x squared, so 2 minus 3 would be negative 1x squared, or just minus x squared. Oops, I wanted that in blue. So we're minus x squared. And then we have a minus 5x, or a negative 5x, and a negative 7x. Combine that and it becomes a negative, or a minus 7, 8, 9, 10, 11, 12, minus 12x. And finally we have a 7 and a 2, which would be a 9, plus 9. Okay? And as you practice with these, it gets pretty fast. So looking at this one here, on the bottom, I see a fifth power, so a plus 4x to the fifth and a minus 10x to the fifth would be negative 6x to the fifth. Then I see a squared, two squareds here, so 3x squared and negative 2x squared would be positive 1x squared. And then we have a negative 2 and a 5. That would be negative 2 plus 5 is 3. And so we'd be done with that one. So in this one, we'll be subtracting this polynomial from this one. The parentheses don't actually do anything in this first polynomial because there's no sign out front, or there's nothing to be added or subtracted over there. So we can just rewrite it without the parentheses. Now the second parentheses, however, do something, because they say, well, all three of these terms need to be subtracted, okay, or we need to take the opposite of all these three terms. So this negative affects the 20x to the third, so it becomes minus 20x to the third, and then we're also subtracting this positive 5x, so we're subtracting 5x, and then we're also subtracting this negative 10x. Sorry, there's no x, so subtracting this negative 10. Okay, so then what happens is subtracting a negative is actually adding, right? So we have this plus 10. So now we're just going to combine any like terms. So I see a 4, so there's this negative 3x to the fourth is the only exponent with a 4, so we can just leave that by itself. Now we have a 5x cubed, positive 5x cubed, to go with a negative 20x cubed. So that's going to end up being a negative, or minus 15x cubed. And I don't see any x squareds. So sometimes what's easy to do here is just cross out ones that you applied already so that you know what's left. So this became the plus 10, so I just want to cross that out. So now we have a negative 2x and a minus 5x, so that's going to be a negative 7x, or a minus 7x. And then we have a plus 5 and a plus 10, which will be a plus 15. And that's it. So we're done with that one. Let's move on to this last one here. Again, these first parentheses aren't doing anything, so I'm just going to remove them. And the second parentheses are doing something, because they're showing that this subtraction has to affect both of the terms in here. So we're going to subtract a negative 12. Now subtracting a negative is adding, right? So, and then we're going to subtract a negative 5, which is adding 5. Now we're going to combine like terms again. So there's only one cubic here, so we're just going to leave it at that, 5x cubed. I don't see any squared ones. So we have some linear terms here. We have a 3x, positive 3x, and a positive 12x, which will become a positive, or plus 15x. And so we can cross these out. We have a 4 and a 5, so that'll be 9. Alright, that should do it for this video. Thanks for watching.